In this video, I'm going to be working through the 4.4 homework exercises on web work. The three laws of logarithms that we're going to use in these problems are posted in our Chapter 4 formulas. So if you go to our class Blackboard page and click on the Chapter 4 tab, then this first link here for Chapter 4 formulas will open up. And we'll see these are what we call the laws of logarithms. So these are the bottom three formulas on the page, which states that if you add two logs, you can combine them by multiplying. So the log of a plus the log of c is a log of a times c. If you subtract logs, the log of a minus the log of c, you can combine that into a log of a fraction, a divided by c. And then the third one is if you have a log of a to the power r, you can take the exponent out and make it a constant multiple. So it equals r times the log of a. So we're going to be using these three properties to answer the 4.4 homework questions. So let's look at problem number one. Problem number one just tests whether if you can use the laws of logarithms to rewrite certain expressions. So if we look at number one, we have the natural log of x divided by y. As we just saw, when you have a log of a fraction, you would subtract the log of the bottom. So this would equal the natural log of x minus the natural log of y. So for number one, the answer would be D. For number two, the natural log of y to the power x, the x is the exponent on the base y. So we can take that number x out front and make it a multiple. So it's going to be x times the natural log of y, which is answer B. For number three, the natural log of x times y, we have a product inside the log, so we can break this up as the sum of two logs. So this will be the natural log of x plus the natural log of y, which is answer C. By process of elimination, the natural log of x to the y is option A, but we see that again, that y is the exponent on the base x this time, so we can take the y out and make it y times the natural log of x. So this is just an introductory problem using the laws of logarithms. Let's move on to problem number two. In this problem, we have to solve for x and get our answer correct to 4 decimal places. When you have a log equation like this, we're going to use the properties of logarithms. Notice that the left-hand side is the sum of two logarithms. So we can combine the left-hand side by multiplying the arguments x and x minus 5. Now we have two logs equal to each other. Logarithmic functions are one-to-one functions, and so the only way that a log of one number can equal the log of another number is if the two inputs are the same. So we can actually drop the logarithms here, and this equation is equivalent to saying that x times x minus 5 is equal to 15x. So if two logarithms are equal when they have the same base, then that must mean that the inputs are equal as well. So x times x minus 5 is equal to 15x. So now we've actually reduced this down to a quadratic equation. So to solve this, I'm going to multiply everything out and put it in standard form. So this would be, on the left-hand side, x times x is x squared, x times minus 5 is minus 5x, that equals 15x. And then I'm going to subtract 15x from both sides to put everything on the left-hand side. So I get x squared minus 20x equals 0. The left-hand side factors, there's a common factor of x in both terms. So if I factor out a common factor of x, I'm left with x from x squared. And I factor out an x from minus 20x, I'm left with minus 20. And then setting each factor equal to 0, I get x equals 0 or x minus 20 equals 0. So we have two potential solutions, x equals 0 and x equals 20. But if we look back at the original problem, you cannot plug in 0 for x. The log of 0 is not defined. Log of 0 is not defined. So x equals 0 is not a solution. Now, x equals 20 is still a valid solution, and if we look at the original equation, if you plug in 20 for x, you get the log of 20 plus the log of 15 equals the log of 15 times 20. And that is a true statement, because by the properties of logarithms, you could multiply these two arguments and combine it into one log. So the only solution to this problem is actually x equals 20. So if I enter that in WebWork and submit, we get the correct answer. So with logarithms, you can't plug in a negative number or 0 into the log function. So log of x is only defined for positive values of x. Let's move on to problem number 3. In problem number 3, we're solving another log equation for x, and we're going to combine the two logarithms on the left-hand side first. So the log base 7 of 4 plus the log base 7 of x equals 1. We can combine the left-hand side by multiplying the two arguments. So 4 times x, and now we have one logarithm. The log base 7 of 4x equals 1. Now we're going back to what we did in section 4.3. We can convert this into an exponential equation. So you take the base 7, raise it to the exponent 1, and that will equal 4x. So we get this log equation equals the same as 7 to the power 1 equals 4x. So these two equations are the same. The logarithmic equation is converted to this exponential equation. And so this is just a one-step linear equation. 7 equals 4x, divide both sides by 4, and we get x equals 7/4. So I enter 7 over 4 for x, and we get the correct answer. Number 4 is very similar to problem number 3. We have a log equation with using the natural log, and the left-hand side is the subtraction of log. The natural log of x to the 8th minus the natural log of x to the 4th. So by our laws of logarithms, we can combine this into one logarithm. It's the natural log of x to the 8th divided by x to the 4th. And x to the 8th divided by x to the 4th, we cancel 4 factors of x to the 4th, and this would just simplify to the natural log of x to the 4th equals 4. So now we're going to convert this to an exponential equation, but recall that the natural log is the same as the log base e. So we have the log base e of x to the 4th equals x to the 4th. So when we convert this to an exponential equation, we take e, raise it to the power 4, and that will equal the argument x to the 4th. So we have e to the power 4 equals x to the power 4. And we, just by comparing the two sides, we see that x has to equal the number e. If we take the 4th root of both sides, and note that we only want the positive root, we see that x is going to have to equal the number e. And so e is that special, it's a special exponential constant that is equal to about 2.718. Now you could enter a decimal answer, but the letter e is defined as this math constant. So use lowercase e and submit, and we get correct. So again, if you entered a 2.718 or 4 or 5 decimal places, you would get the correct answer as well. So the final problem in section 4.4 is actually a pretty challenging problem. So we have this exponential equation, 5 to the x minus 1 equals 3 to the power 2x plus 1. So in order to solve this equation, we're going to use the law of logarithms that says if you take the log of a base to a power, you can move the exponents down. So you can choose any log you want, but typically we use either the common log, the log base 10, or the natural log. So it's kind of up to you. I'm going to choose the common log, so I'll take the log of both sides of this expression. And then using the third law of logarithms, I can move these exponents out front. And since these exponents are polynomials, we need parentheses in front. So I would have parentheses x minus 1 times the log of 5 equals parentheses 2x plus 1 times the log of 3. So this is actually just a linear equation now, and once we get used to using logarithms, we can just see that log of 5 and log of 3 are just real numbers. So in order to solve this linear equation, I need to distribute this factor of log 5 and log 3 on both sides, and kind of break up these parentheses. So when I distribute the log 5, I'll get x times log of 5 minus 1 times log of 5. And on the right side, I'll get 2x times log of 3 plus 1 times log of 3. So now, in order to solve for x, I'm going to put all the terms with x on one side, and then I'm going to move all the constant terms to the other side. So I'm going to actually add log 5 to both sides. And to move the 2x log 3 to the other side, I'm going to subtract 2x times log of 3 from both sides. So I end up with an x times log of 5 minus 2x times log of 3. And on the right-hand side, I have a log of 3 plus log of 5. And on the left-hand side, to isolate the x, I'm going to factor out an x from both sides. So I'm left with log of 5 minus 2 log of 3. And that equals log of 3 plus log of 5. And to finish this off, I'm going to divide both sides by log of 5 minus 2 log of 3. So I would just get x equals the log of 3 plus the log of 5 divided by the log of 5 minus 2 log of 3. So it's not a particularly nice expression. You could enter your answer just like this. You could type in a calculator and get a decimal value. We could also simplify this. The log of 3 plus the log of 5 would be the log of 15 when I multiply the 3 times 5. And then log of 5 minus 2 log of 3. 2 log of 3 would be the log of 3 squared, which is 9. And then log of 5 minus log of 9 would be log of 5 over 9. So this might be a little bit easier expression to type into WebWork. And if I enter a decimal expression, it's about negative 4.607. So that would be a decimal answer. So I'm going to start by entering an exact answer. So put parentheses for the numerator, log of 3 plus log of 5. Close the parentheses for the numerator, divided by parentheses log of 5 minus 2 log of 3, and then close the parentheses for the denominator, and we get the correct answer. So again, you can see from what I entered, it gives me the decimal value, negative 4.607. That would be a correct answer as well. So if I type in negative 4.607, submit, that would also be accepted as a correct answer. All right, so this one was a little bit more challenging. It has a lot of algebra, but it's using this properties of logarithms that you can take the log of both sides of an equation. And this finishes the 4.4 homework problems.